Hi, this is Suresh. Welcome to Rock Tutors. Today we are going to discuss a new topic, formation of images by lens. This topic is in the same chapter what we discussed in the previous video. In the previous video, we discussed some general terms related to lens and kind of lens and nature of the lens we discussed in the previous video. This topic is continuous of the previous topic. This topic is little bit lengthy. I decided this topic will discuss in two sessions. In the first session, we will discuss to form an image, what we require and what is image and kind of images we will discuss in this session. In the next session, we will discuss about ray diagrams, how the image will be formed and kind of images and nature of the images and position of the images and everything we'll discuss in the next video. For more details, like, share and subscribe. Don't skip the video. Watch till the end. This video will help you to understand the concepts. ఈరోజు మనము ఫార్మేషన్ ఆఫ్ ఇమేజెస్ బై లెన్స్ అనే టాపిక్ని మనం చూద్దాము. ఈ యొక్క టాపిక్లో మనం ముఖ్యంగా ఇమేజ్ ఫామ్ అవడానికి మనకి ఏమేమి కావాలి, అలాగే ఇమేజ్ అంటే ఏంటి, ఇమేజ్లో ఉన్న రకాలు. ఈ యొక్క టాపిక్ కొంచెం లెంగ్తీగా ఉంది కాబట్టి ఈ యొక్క టాపిక్ని 2 సెషన్స్గా డివైడ్ చేసాము. సెకండ్ సెషన్లో నెక్స్ట్ వీడియోలో మనము ఇమేజ్ ఎలా ఫామ్ అవుతాయి అంటే రే డయాగ్రామ్స్, అలాగే ఇమేజ్ యొక్క పొజిషను, సైజు, నేచరు, ఇవన్నీ కూడా నెక్స్ట్ వీడియోలో మనం డిస్కస్ చేద్దాం. సో వితౌట్ ఎనీ డిలే విల్ గో ఇంటూ ద టాపిక్. Our topic, formation of image by lens. Now, formation of image by lens. Now here, through lens, how the image will be formed. Suppose this is a lens I am taking. This is the object I kept here, and this object image will be formed somewhere here. How that image will be formed? So when these rays are passing through the lens, and it will be refracted and it meet somewhere, and where there is all the refracted rays are meeting, their image will be formed. Now we know that, this is object, through this object so many rays will be come, so many directions like this. The rays will be goes like this, like this, like this, like this, and so many ways the rays will be goes. Then to join these rays and forming the image, it will be more complicated to understand the formation of image. For that purpose, how many minimum rays required to form an image? To form an image, we required minimum 2 rays. That's why instead of studying of all these rays, if we study only few rays, how the rays will be behaves, then you can understand the formation of image by lens. The few rays are called principal rays. We'll see what are principal rays. Remember to draw a ray diagram, so carefully observe how to draw the ray diagrams. Now, this is the lens, convex lens, principal axis, this is the optic center O, and this is F2, and this is 2F2. So take here F2, suppose the distance is from optic center to F2 is a x centimeters, and this also take the same distance, same measurement is F2 and 2F2, both are x centimeters. And here also from O to subtaking this is F1, this is also x centimeters, and so another one is the 2F2, F1 and F2, the distance between F1 and F2 also same x centimeters. Suppose this is 2 centimeters, this is also 2 centimeters, this is also 2 centimeters, this is also 2 centimeters. This is all. Now, first principal ray. If a ray is parallel to principal axis, the ray is parallel to principal axis incident. This ray is incident on the lens parallel to principal axis. So you know that after refraction, it will be passed through the focus. It pass through the focus. So this is the focus. And second principal ray. Suppose second principal ray passing through the first focus, first focal point. After refraction, this ray is incident. After refraction, this will be parallel to principal axis. This is the second principal ray. The ray is passing through first focal point, then after refraction will be parallel to principal axis. Now third ray, this is the principal axis, F2, 2F2, F1, 2F1. The ray is passing through optic center. Ray is passing through optic center. We discussed it yesterday. When ray is passing optic center, it will not deviate. It's undeviated, and it will be go straight without any deviation. So these are three principal rays. A ray is parallel to principal axis. After refraction, will be pass through focus. The ray is passing through first focal length, first focal point. Then after refraction, will be parallel to principal axis. The ray is passing through optical center. It will be without deviation. This ray is undeviated and it will be go straight. These are the three principal rays. By using any two rays of these three rays, we can draw ray diagrams. Now, if I am taking concave lens, then how these rays will behave. This is a concave lens. For concave lens also same. Principal axis, optic center. Here this is F1, 2F1, F2, 2F2. First principal ray. A ray is parallel to principal axis. A ray is parallel to principal axis. You know that? So in this lens, this is a concave lens and this is also called a diverging lens. So in this lens, the ray is incident on the surface. After refraction, it will be move towards the base of the prism. It is move away from the principal axis. This is the principal axis away from the principal axis. This is the way. So if that ray is parallel to principal axis and after refraction it will be move away from the principal axis. If I extend this refracted ray towards the back side, backwards, then it will be meet at a second focal point. It will meet at second focal point. Now, second principal ray. Yeah. This ray is passing through focus, then after refraction it will be parallel to principal axis. So now this ray is appears. It is, if this lens is not there, this ray is meeting at the here at this point. And because of this lens and this ray is refracted and it is parallel to principal axis. This is the behavior of the ray when it is fall on the concave lens. This ray will be refracted and parallel to principal axis. Now third type, third principal ray. Same, the ray is passing through optic center. The ray is passing through optic center. What happens? The ray is without deviation will be go straight. It go straight. So this is a way that rays will be behaves when the rays passing through the concave lens. We will use these principal rays and we will draw the ray diagrams. We will see in the next video. Our next topic, kind of images. Now, what is mean by image? Image, when image will form? So when rays are after refraction, refracted rays where they will meet. Suppose these are rays after refraction, they are meeting here, this point, at this point. This point we call as a image. So maybe these refracted rays maybe meet at the point really, or maybe if that refracted rays, if I extend it backwards, they will meet at a particular point, somewhere it will meet. That point is called a image. We'll discuss about kind of images. These images are mainly two kinds. One is real image and another virtual image. So real image means what? So after refraction, the rays, they are meeting really at a particular point. So then that image is called a real image. Suppose a convex lens, the rays are incident on the surface, and after they are meeting here and here, that image forms. So here what happens? The rays are really meeting. After refraction, they are really meeting. So this image is called a real image. Now virtual image. Now here, this virtual image means the image will form after refraction, the refracted rays not meeting really. They are meeting, but they are not meeting really. So that image is called a virtual image. For example, for concave lens, you know that these rays after refraction, they are diverging. So these refracted rays, they will never meet. If I extend it backward, then they are meeting here. Then image will form here. So this point is not actually, these rays are not meeting, because these rays are diverging, they are going away after refraction. But I am extending towards the back side. So then these rays meeting here, then this image forming here. This is called a virtual image. Next, this real image we can capture on the screen. If I kept screen here, then we can see the image on the screen. But here we cannot obtain image on the screen. Virtual image we cannot obtain on the screen. Real image we can obtain on the screen. And next point is that, so these real images are inverted. These real images are inverted. If this image, this object is upright like this, and this image will be inverted. And for this, image is always erect. Erect means straight. The virtual image always erect, straight. These are the main differences in the images. In the next video, we will discuss more details about ray diagrams and how that image will be formed. I hope you understand this concept. See you in the next video. Have a great day.